This is an EOC review for radicals. Okay, what is a radical? Radical is this fancy looking divisor bar, right? It means the square root or the cube root or whatever of anything. Okay, so there's like exponents. This is the base of the exponent, this is the exponent, and then you have a coefficient, right? So this is b to the n times c. You could have like something like 3 times 4 raised to the third, right? And you would have to take 4 to the third, which is 64, right? No, 32, excuse me, 32, and then I think it's 4 to the third, hold on. 4 times 4 times 4, 64, yep, 64, and then multiply it by 3 to get your answer of 192 here, because the order of operations. Okay, but a radical, this is the base, this is the exponent, this is the coefficient. A radical is similar but different. Inside the radical you have your radicand, which is similar to the base. Okay, then over here you have the index, and you can have the exponent here or here. It doesn't matter, they're the same thing, right? So if you have a radical like this and there's no number there, it's an indivisible 2. Okay, so this would be like the square root of 4 is 2. Okay, another way to write this in exponential form is if you go, this is the denominator of the exponent and this is the numerator of the exponent. So say you had something like the square root of 3 cubed, you could have it there or there, right? This is 3 cubed, take the square root, or so it would be square root of 27, or it would be the square root of the cube, 3 cubed squared. Either way, it's going to get the same answer. Okay, but this is the base, right? This is the denominator, and this is the numerator. Okay, so this is 3 to the 3 halves. And if there was a coefficient in front of this, say like 2, it would be 2 times 3 to the 3 halves. Okay, so that's different ways to write exponents and how they go from radicals to exponents and vice versa. Right, so for different radical rules, right, consider a radical like a variable, right? Like x or y, right? You know, if you have 3x plus 2y, you can't combine those two together because they're unlike terms, right? But if I had 3x plus 2x, I could make that 5x. Similar to that, say I have the square root of 2, and I have 3 times the square root of 2 plus 2 times the square root of 3, right? These are not the same variable, if you will. They're not the same radical, right? So I can't add these together, right? But if I had 3 square root of 2 plus 2 square root of 2, these are the same. So I can add these together, so this would be 5 square root of 2. All right, so that's another way to look at it, which again is 2 to the 1/2 times 5, right? So that's the same thing, right? So if I was going to multiply one, say I had 3 square root of 2 times 2 square root of 2, right? I can multiply the 3, the big, right? Multiply the 3 times the 2, which is 6, and then multiply the 2 times the 2, which is the square root of 4. Square root of 4 is, you multiply the two things together, that's going to be, comes out as a 2, so this is going to be equal to 12, because 2 times 6 is 12, right? So say, for instance, I have something that is inside of a radical, like, let's see, like square root of 972, right? And I want to reduce that. Okay, the idea of reducing this, say 9 square root of 72 over we'll do times the square root of 27. Okay, so at face value this looks pretty complicated, but if you break down each, the numerator and the denominator, into different things, there might be a chance that you can eliminate the radicals. Okay, so you need to put this thing in simplified radical form. 972 is not a prime number, nor is it a perfect square, but I can start dividing these things by a perfect square to see if I can pull that perfect square out. This is what it looks like. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if I square these, I get 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, now start this 972. Let's start dividing that by any of these perfect squares. Okay, this is 100, not 107. So 972 divided by 100 is not a integer. Now let's do 972. 972 divided by, we'll say 81. Right, well that's 12. Okay, so this breaks down into the square root of 81 times 12. Well, this 81 is a perfect square. So I can pull that out of the radical, and the square root of 81 is 9, right? So this is going to be 9 times the square root of 12. But I'm not done yet. The thing inside my radical is still not a prime number. And I wonder if 12 has anything that could be broken down into perfect squares. Well, 6 times 2, 6 times 2, that doesn't work because neither of those are perfect squares. But if I do 4 times 3, those are the factors, those are perfect squares. So 3 times 4 is 12. So this equals 9 times the square root of 12, which is 4 times 3. This can come out as a 2, right? So this is going to be equal to 2 times 9 square root of 3, and this equals 18 square root of 3. So that's just the numerator. That's just the numerator. Let's do the denominator. Right, so the denominator, I can divide 27 by 3, right? So 27 divided by 3 is 9. So this equals 9 times the square root, the square root of 9 times 3. This is a perfect square. Bring that out. That is 3 times the square root of 3, and that's as simple as it can get. So this is going to be 3 square root of 3 as my denominator. So now here, if I have a square root of 3 divided by square root of 3, if I have something divided by that same something, right? If I have x divided by x, it equals 1. If I have pi divided by pi, it equals 1, right? So this 3 divided by 3, those cancel out to a 1, right? So 1 times 18 is 18. 3 times 1 is 3. 18 divided by 3 is 6, right? So here you can see that is all how that all goes together. Okay, identifying and reducing these is super important. One last thing, right? Say you have 2 square root of 3 divided by the square root of 2. Okay, by a general rule of thumb, we do not leave radicals alone in the bottom. Okay, with no radicals in the denominator. So I need to multiply this by some value of 1 that'll help me get rid of the square root of 2. Right, so I need to multiply this thing by the square root of 2 over the square root of 2, which is 1. I'm not changing anything because I'm multiplying it by 1, but I have to do the numerator and the denominator. Right, so I do 3 times 2, which is 6, so the square root is 6, and then I have the 2 on the outside. Square root of 2 times square root of 2 is the square root of 4, which is 2. Right, so now I have 2 divided by 2 times the square root of 6 divided by 2, right? Which those cancel out, so I have the square root of 6 as my final answer. Okay, so that is a little bit neater there to figure out all your radicals. That was a real quick crash course on radicals and how to use them. Slow down the video if you need to, watch it again. If you have any questions, please let me know.